people have already stated that tomorrow is a vacation. So this is Friday.
Yeah, no, I get that feeling. Yeah, I get that feeling.
You should have seen him earlier.
Hamish, do you mind getting that blind there? Benita, do you mind getting the blind at the back there? Joshua, get that blind at the back there, thanks. And give us a check there. Thanks. Now, page 92. So we're having a look at line graphs here. So, line graphs. So what we need to know about line graphs. First thing about a line graph is what goes on the x-axis is always a time. So line graph is xy graph, but the x is always a time. You always put time on the x-axis. So firstly, x-axis is a time. And y is just whatever you're measuring. So it could be, for example, things like sales, or something like tax, GDP. If I think in your biology or chemistry you measured something like enzyme activity as across time, yeah. So this is another example of a line graph then. So I'll just put in bio stuff. And of course, physics students, a line graph for you would be time and velocity would be a line graph for you. So we could have then velocity on the y-axis. Okay. The other thing about line graphs, we usually connect the points with straight lines. So we join lines between all the points on the graph. This is sometimes different in biology. You should really draw a curve. But line graphs have straight lines between the points. So line graphs have lines joining the points. So I will just give you an example of a line graph and then we'll look at how to draw one. So what you should be picturing for your graph is you have an x, which is a time, you have a y, which is something else, and it doesn't have to be a straight line. It could be something like this. It just means it's called a line graph because each connection is a straight line. Okay. And like I said, bio, you shouldn't be doing this in the bio exam. In fact, you could lose marks if you did this. You want a curve. It happens, yeah. If you want to see what a victim of this looks like, it's right there, is it? Which exam?
It was just a practice exam.
Practice, forget about that. That was a real exam, just a practice exam.
Oh, but you would lose a mark if it's not a straight line or a fixed.
Yeah. Okay, so let's have a look at some data and we'll put this in a graph. I can scroll down? Yep. So one of the units must be a time. So in this example here, the time is the year.
Yeah.
2005, 2006, 2007, 2008, and look guys, we need to settle down. What's wrong, Hussein? What are you getting? Fine, come on. And then here would be sales in thousands of euro. So maybe this one is 4,000, 5,000, 5,000, 4,000, 2,000 as an example. Okay, so I have 1, 2, 3, 4, 5. So I need 5 equally spaced unit markings on the x-axis. Now you don't have to start this one here as 2005. You can if you want, but I think it's a little bit neater to start it from here. 05, 06, 07, 08, 09. And we'll have here 1, 2, 3, 4, and 5, and this here is sales in thousands of euros, and this one here is the year. So now, you are expected to do this on graph paper, and you're expected to be very neat and accurate in the exam. In fact, the marking scheme would often say that students should be accurate to 1 millimeter for this graph. Yeah. So look, you just need to do it very neatly and carefully with a pencil. Okay. On graph paper, which you'll get. Yeah. So the first value here is, 1, 2, 3, 4, and 5. So the first value is 4, and then there's a 5, a 4, and a 2, like this. Let me just see. Although it's not included, here's a 10. It's not included, I know. But there's an extra question I want to add in. Okay, so straight lines between them. So there's the first one, the second one, the third one, the fourth one. Now I'm getting tired, getting really tired, so just focus here, okay? Question, was there? Sorry, yeah.
So would we have to deal with uneven numbers that would fluctuate when it comes to the...
Oh yeah, there's no reason that this has to be in a nice straight line. It could go up, down, across, up, down again, yeah.
Yeah, but when we're drawing the y-axis,
yeah.
Would we have like 4, 5, and 20?
Nah. They always try to keep them like, you know, yeah, you wouldn't have something like 4, 5, 5, 4, 2, 20. You know, they'd be close together. Because it's too difficult to draw accurately if this did happen. So you shouldn't, no, don't worry about this. So you call to do this on graph paper, you do it nice and neat. Right, Joshua, get out. Now Joshua, don't make things worse. Joshua, I just saw you messing there. I don't know what you're doing, and you're doing something with one of the people beside you there. Joshua, please, just don't make this difficult and just get out, okay? You're just wasting my time now protesting. Just go.
Come on, you finish the question.
Joshua, I'm not teaching right now because I'm waiting for you to go. Just go. And you two, okay? Don't say anything, just listen to me now. If I get trouble from the two of you down the back, you'll be joining him, okay? Now, for this one here, first part of the question would just be something like, draw the graph. That's fine. But then would be asked to do something where you need to use the graph. Question, yeah?
When we do the graph,
Yeah.
the axis, do we have to start with the empty the first line?
No. I said that if you want, you could start here. But I feel it is better not to do this. I think it makes an easier, neater graph if you start a little bit in. So for line graphs, you don't need to make this 0. You can start at any point on the x-axis. Although I really feel like the y should start at 0 still. So like here should still be 0. Now, doesn't have to be 0. Especially if you have numbers like 100, like if you have 104, 105, 105, 104 and 102, you don't want to start at 0 there. What you do in that case is you do something like this, 0, and then, I'll draw the symbol again. Tell me if you've seen this in bio or chemistry, this symbol here. Oh, you have? So this means 0, and then you skip to 100, 101, 102, yeah, 103.
So now we're graphing the same thing as symbol on the x-axis, right? On the graph that you drew?
No, it's for line graphs, it only needs to go on the y-axis.
But then the next axis we have from 0 to 5, and then the same graph is from 10 to 6.
No, yeah, good point.
Here, 2000.
This is not 0 on the x-axis.
Yeah, so but what do we put?
You can leave it blank.
That's
Because on the x-axis is time, and here time is a year, but time could have been a month. So you could have written here January, February, March. So then this is definitely not 0, because there's no month called 0.
So we are allowed to leave x-axis blank.
You mean at the beginning?
Yes.
Oh yes, definitely. Although not maybe the y. You should put something in for the y.
It doesn't like between each two, that's a year, 12
Yes.
years in between.
Yeah.
So between 0 and 2005 is not 2005 years, it's 1 year. Doesn't that indicate like that?
Yeah, like I suppose here, if you want, this would really be like 2004. But what I'm saying is, it doesn't matter and it's fine, and you can start, this can be anything really. So if I put this as 05, if you want you can think about this as 04, if you want. But I mean, it's not a problem, because it could even be months, January, February, March. So it doesn't even have to be a number, it could be a name.
Okay.
The y-axis needs to be a number starting at 0. If it doesn't start at 0, you need to include the break symbol. You can only include the break symbol once. So don't do something silly like break 101, 2, 3, 4, 5, break. Okay, don't do this. Now, the reason you have to be really, really careful with your graph is because then the following question could ask you to use the graph. So for example here, they might say, from your graph, what was the number of sales in the middle of 2008? So on your graph you have to very carefully with your ruler start at the middle of 2008, go up and across, and then the answer will be here, 3.25 thousand euros of sales. Likewise, they could ask you the other way around. They could have said, when were the sales 3,000? So in that case, you would go the other way. So we start at 3,000, we go across, and then down. So you can see that would be 2008, around about September, October, something like this. So this is why in the marking scheme it says it is important that students are accurate, and the mistake that's allowed is only plus or minus 1 millimeter, which is, if you look at your ruler, that's small. So not only should you use a pencil, you should use a sharp pencil. I know it seems like it's asking you a lot, but it's not really, because this is the question where you would get 15 out of 15. Like most students here score 15 out of 15, 14 out of 15, or 13 out of 15 if they practice. So this is the question that will help your marks in the final exam. So don't waste it by being messy on the graph paper.
The big question.
It would be part of a question. So for example, the other part of the question might be something like, what is the average number of sales? What is the standard deviation of the sales? What is the upper and lower and median of the sales? The upper quartile, the lower quartile. So usually the statistics question goes as follows in section B. First part, what is the average? Second part, what is the standard deviation? Third part, draw a graph. Fourth part, use the graph. And then the fifth part could be anything else, maybe related to the graph or to another calculation or something like this. But I know it's every single year they always ask you for a graph in the statistics question. They always ask you to use the graph, and they always ask you to calculate the mean and standard deviation. So it's a fairly safe question as well. And there's only 3 types of graphs anyways, so this is just one of the 3. And we'll look at the other 2 as well. Okay. Now, in fact, that's it for line graph. Okay. So it's a really small topic. So before I let you practice some, there were some questions I know people were having from the workbook, which I'll do. So I know Tanis, you had one question from the workbook. So maybe you want to get it. So just before I let you work on these, I have a few minutes for doing questions from the workbook if anybody was practicing them and they need to see something. Now if you weren't practicing them, why weren't you practicing them? And if you were, if you have a question, let me know, I can do it now. So what page are you looking at, Tanish?
26.
Okay, so 26. Question, of which one?
4B.
Yes, thank you, 4B. There's actually 4B questions on it, so... I'm going to do 4B on 26. Can you have a look at it, please? You have it there? Okay, let's have a look at this. Integrate 9 over 9x squared plus 54x plus 82 dx. I don't need this now, so you can take it back, thanks. Okay, so in the question, I give you a hint. You should complete the square. So let's have a look at doing that. And I'll take the 9 out on top, and I'll take the 9 out on bottom. So I have 9 over 9, integrate 1 over x squared plus 6x, and this will be plus 82 over 9 dx. Well, that's actually nice that those 9s cancel. So this is 1 over x plus 3 squared plus 82 over 9 minus 9 dx. Now, that's 1, yeah, because that's 81 over 9. 82 over 9 minus 81 over 9 is 1. So this is integrate 1 over x plus 3 squared plus 1 squared dx.
109.
Oh, sorry, 1 over 9, thank you. 1 over 3 squared. So what do we say the trick here for the substitution is? You let u equal the square root of x plus 3 over 1 over 3. Oh yeah, and these are squared and they cancel the square roots. So it's x plus 3 over 1 over 3, which is 3x plus 9. So that means du dx equals 3. So therefore, dx equals du over 3. So you should put that back in. You should put this result back in. And also here, you can say that u minus 9 over 3, that's equal to x. So you take that result and put it back in. You can put it in here. And you take this result and put it back in as well. So this would be 1 over...
Can't we put u squared over 9?
Yeah, that's fine as well. Whatever way around, it's fine. U minus 9 over 3 plus 3 squared plus 1 over 3 squared du over 3. So this will become 1 over u over 3 minus 9 over 3. Minus 9 over 3 is minus 3. Plus the 3 cancels, so you're just left with that. So this 3 squared and 3 squared is 9, so it's 1 over 9, 1 over u squared plus 1 times 1 over 3 du. So it is 1 over 27 integrate 1 over u squared plus 1 du. This is tan inverse, isn't it?
Yeah.
Yeah.
Mr. Stewart?
Yes.
It's talking about minus 9.
Sorry, it's 1 over 1 over 9. Yeah.
So it's 9.
So it's 9, yeah. So 9 over 3 is 3. So this is 3 tan inverse u plus c. 3 tan inverse, I don't remember, what did I say the u was? 3x plus 9 plus c. Now if the answer is wrong, I'm sorry, but is that the answer at the back? So what went wrong for you?
It's not on that one. Yeah, on the
Sorry, let me just, now put your hand back there. Let me put it back. Right, hang on. Yeah, no, I understand, that is a tricky part. Alright. Any other questions? With the 9? Yeah. Where did the 9 come from?
No, I'm sorry, the fifth one.
From the bottom?
Yeah.
1, 2, 3, 4, 5. Here?
Yeah.
Yeah, what was the problem with this?
I couldn't bring it from the fourth to fifth level.
Oh, here to here? Well, this here is u over 3 minus 9 over 3 plus 3 squared. They cancel.
Yeah.
This is the problem, was it? Yeah. Oh, you didn't cancel. Made it messy, was it? Sit down and don't give me any trouble. Is there other questions in the workbook? Yes, please. 1 over 3 squared, yeah. That's the trick here. You let u equal the square root of the first piece over the second piece. It's always this trick for these problems. So if I just go back to the start here. If you look here, Grace, whenever you have these types of problems, a thing squared plus a thing squared, the u is always square root the first piece, which is a square, of the second piece, which is a square. And the square root and the square is cancelled.
What is the square minus square?
Yes, if when you complete the square, you get a minus. Good question. Sorry, can I scroll down to that example? Yeah?
I have a question.
Yes.
How did you get, second line from the top,
This one.
fourth, to the third, sorry.
Here to here?
Yeah.
How did I get that?
Yes.
Well, this in the denominator is, here is u squared over 9 plus 1 over 9.
Yes.
So one way you can think about it, Ali, is you multiply the top and bottom by 9. That will cancel the 9s there, leaving you with a 9 on the top, which is what's here. Because this is like 9 over 1. Okay, can I scroll down now? So, Asun was saying, this works, or, these usually have a plus in them. But what happens if you had a minus in them? In other words, how would you integrate something that maybe looks like this? 1 over x squared minus 1 dx. Or even, I know you might mean something more complicated, like 1 over x minus 2 squared minus 9. But it's the same idea for both, it's just this is simpler. So who has any ideas for how you would integrate something which is 2 squared minus the subtraction of 2 squared instead of the addition? Yeah. If this here was a minus, it actually meant the quadratic had factors, and you should factorize it. So here, the minus means it has factors, and in fact you just spotted what the factors are. It's x minus 1 and x plus 1. Now, if it was a minus, it meant it had factors, so you could have factorized. Now that we factorize, what do we do? Nope. Uh-oh.
That's by substitution.
What's this called?
By part?
She knows it, she just can't remember the name of it. What do we do? Yeah. No, not by part, Ali just said that. Yeah, go on, say it again. Yes, that's right. So, what you need to do is change this into partial fractions.
Isn't that by part?
No, by parts is by parts.
The price is the whole of the time.
Yes. No. And then how do you do each of these as separate problems? It's just log actually, it's in the formula book. These are both logs. But if they weren't so simple, you could just do both by substitution. Although they would both be logs. And we have looked at this type of problem when we did integration of proper partial fractions. Oh yeah, no, you're thinking of integration of improper partial fractions.
Oh,
that was very
the worst
bad.
one.
Yes, they were the worst of the worst at the end of the chapter. Okay, so I'll let you work on those line graphs for a few minutes then.
What is a grid line?
Grid line are those horizontal and vertical lines. So what do I say? Yeah. When I was making this worksheet, it's so specific, I am trying to think of what possible extra questions could I get in. What else can I do?
Isn't this just 1 over x plus 1?
It is not.
Minus 1.
It's not either of that. No. You have it backwards, Ali. Integration of 1 over 1 plus x squared is tan inverse x, not the other way around. Yeah.
Then how do you do this?
Yes, how do you do that? I'll give you a hint to get you started, okay? So what you should do is change this into tan inverse x multiplied by 1 dx,
Oh,
and then use by part.
what about this?
Have a guess. What do you think the trick is here? I give you a clue.
Then it's
like that.
This one over X?
No, you've got them backwards again. Yes. Log x times 1 dx, and use by parts.
This was the LIATE.
The whole lesson had LIAT in the journal.